In 7.1 and 7.2, we estimated mu. But if you'll notice now, we are going to be estimating mu1 minus mu2. So that tells me I have two populations. Mu1 would be population 1 and mu2 is population 2. So in this section, we will now have two sets of data, and we are going to estimate the difference between their population means. It's similar to 7.1 and 7.2, but the conclusion is different. So the big difference is the conclusion. So we'll really spend some time on that when we get to it. Now, since we have two populations, that means that we will be drawing two samples. And those samples can be independent samples. When a sample drawn from a population is completely unrelated to the selection of sample data from another population. We could also have dependent samples when each data value in one sample can be paired with a corresponding data value in the other sample. But what's important for you to know is we will be confining our study to only independent samples. So for us, our two samples will be completely unrelated. So when we draw those samples, we're looking at the difference of the two population means, so we then need to also consider their standard deviation, which is calculated as the square root of sigma 1 squared divided by n1 plus sigma 2 squared divided by n2. And the 1s and the 2s are used to distinguish between the two sets of data. So this sigma 1 squared and n1 came from population 1. These two values, because they have the 2, came from population 2. Now, again, we're dealing with independent samples. And of course, what you have to watch for is whether sigma is known or unknown. So first we're going to look when sigma is known. So when sigma is known, we have our formula for calculating the margin of error. So since sigma is known, we'll use Z sub C. So that means we will use the little table in this corner. Excuse me. And the confidence interval, if you'll notice, it is different. Now we still subtract E and we add E, but notice we have the difference of our X bars minus E and plus E. And of course, what we are estimating is the difference of the population means. Now this leads us into the conclusion, and it is in the conclusion that is different than what we have done so far. So this is what you have to pay attention to. All right, we don't care about the numbers we end up with in the confidence interval. All we need to be concerned with is what are their signs. So say you calculate your confidence interval and you get a positive number on the left and a positive number on the right. So what you want to do is ask yourself, what always happens when you subtract two numbers and the result is always a positive number? So when you subtract two numbers, whatever they may be, but your solution is always positive, then that forces mu1 to be the larger number. So if I get two positive numbers, then I know the population mean is bigger in mu1 than mu2. When you subtract two numbers and you always get a negative answer, that tells me that the mean in set 2 is always larger, because a smaller number minus a larger number always yields a negative solution. Now, sometimes what might happen is that you get a negative value and a positive value. If that is to happen, then that means that there is no significant difference. Because now I cannot say that mu1 is always larger or mu2 is always larger. When there's no significant difference, it means sometimes mu1 could have the larger mean and sometimes mu2 could have the larger mean. So we say there is no significant difference. So again, remember that sigma is known here. All right, so here's an example. Which battery lasts longer? So we're comparing Duracell, which N1 is 42, X bar is 9.8, and sigma 1 is 2.2. So this is population, or mu1. Energizer, so this would be mu2, and it gives us our information there. All right, so we're asked to find a 90% confidence interval for the population difference, mu1 minus mu2, of lifetimes for these batteries. Since sigma is known, then I know I have a z sub c value. It's 90%, so I come to the 90%, so I'm going to use 1.645. Now I'm going to calculate the margin of error. So now I'm going to apply this formula right here. Z sub c, 1.645, times the square root of sigma 1, so 2.2, squared, divided by N1, 42, plus sigma 2, 3.5 squared, divided by N2. And I'm going to put this into my calculator. 1.645 times the square root of 2.2 squared divided by 42 plus 3.5 squared divided by 38, right arrow out from under the radical, enter, and we get 1.088. You know, on WebAssign, you'd probably want to go out further. For purposes of notes, I'm going to go out 2 decimal places, so approximately 1.09. There's my margin of error. So then my confidence interval, all right, so this, because we have 2 sets, is different slightly. So I have on either side, instead of just x bar, I have x bar 1 minus x bar 2. So my interval would look like this. X bar 1, which, get where you can see it, there it is. So we would have 9.8 minus 8.1 minus the margin of error. And then we have x bar 1 minus x bar 2 plus the margin of error. Now, we can do this calculation, and that's fine. This would give me 0.61, and over here I would get 2.79. But those numbers don't have any significance at all. All I'm cared about knowing is that this yielded a positive number and this yielded a positive number. Because again, if both of these are positive, it's up here, if both come out to positive, then that forces, and we know that mu1 is larger. So over here, since they're both positive, I'm going to say mu1 is larger. Now here's why that is important. Mu1 Duracell is larger always than Energizer, so that tells me that Duracell lasts longer than Energizer. So when I go to my conclusion, I say I am 90% confident the average life of Duracell is longer than energizer. So if you'll notice, now in our conclusion or our explain, we do not include these two values because they don't have significance. But being that these were both positive numbers, it tells me that Duracell lasts longer than Energizer. So that is an example when sigma is known. And when sigma was known, we used the Z sub C value. So now, again, we're still only dealing with independent samples. But now we're going to look when sigma is unknown. Well, when sigma is unknown, then we have to use the student's t distribution that we've learned about. So my margin of error is in essence the same, except now it's t sub c instead of z sub c. And we have S, or the sample standard deviation, instead of sigma. Well, if we're using the student's t distribution, then we have to consider the df. Well, the df is n minus 1, but we have two n's. So you'll always use the smaller minus 1. You don't find two df's, you just find one. So look at your two sample size and use the smaller sample size minus 1. And then your confidence interval is calculated the way we just calculated it on the last example. So let's take a look here. Assume absorption times are normally distributed. Find a 90% confidence interval for the difference in average absorption times for the two drugs. So we're comparing Tylenol to Advil. And if I'm achy, then I want the one that absorbs quicker. Okay, now what you need to recognize is that they gave me S. So that means sigma is unknown, which means in my margin of error I will find, or I will use T sub C. So C is 90%. And I know I need my DF, which is n minus 1. Well, we have two n's. We have 8 and we have 10. You don't find two DFs. So this is an example where it says use the smaller sample size minus 1. So I'm going to use 8 minus 1 or 7. So to find T sub C, I'm going to pull up the student's T distribution. We're using 7. And 90% is 0.900, so we're going to use 1.895. So to calculate my margin of error, it is 1.895 times the square root of S1 squared, so 3 squared, divided by n1, 8, plus S2 squared, 4.9 squared, divided by n2, which is 10. So when you put that into your calculator, 1.895 times the square root of 3 squared divided by 8 plus 4.9 squared divided by 10, come out from under the radical, you get approximately 3.56. Again, I'm rounding to 2 decimal places. Be careful on WebAssign. Then our confidence interval will be x bar 1, 24 minus 29 minus 3.56. And x bar 1, 24 minus x bar 2, 29 plus 3.56. And again, I'm not interested in the numerical values here. I'm interested in whether they are positive or negative numbers. So when I look at this, 24 minus 29, that's -5. -5 minus 3.56, that's going to yield a negative number. Here I have -5 plus 3.56. -5 is bigger, so that means this will give me a negative number as well. And if you go back to your conclusions, if they're both negative, you know mu2 is larger. So then your conclusion, I am 90% confident the average absorption time for, okay, mu2 is larger, so Advil, the absorption time is longer, or it is slower. So the absorption time for Advil is slower than Tylenol. And that completes chapter 7.